Desi here, g'day, and welcome back to another BTLO Replay. Today I'm going to be going through Ghosted, which is a hard IR lab that was retired in October in 2023. But before we do that, be sure to follow us on X, LinkedIn, or join the Discord server that we have and be part of the awesome BTLO community. As always, links will be in the description box below, but for now, I've already fired up the lab. Let's read the scenario and some of the questions and get into it. WeLoveDogz LLC does not have enough funds for testing environment and their one-man IT department, this is not uncommon, John set up a new server straight into production while still being configured. Unfortunately, the server got compromised and John does not have a clue how this happened. Luckily, he was able to obtain a packet capture, a log from Suricata IDS IPS, and a TTY report for the auditd running on the system. Help John understand how his system got compromised, and then we go into the questions. So to start up with IDS IPS, not familiar, intrusion detection system and intrusion prevention system. Sometimes you'll get systems that are one or the other, or you'll have one that can be configured in a certain mode. And by default, it's set usually to IDS because when you're doing IPS and you start blocking things, users complain. The downside to that is people forget to switch or tune from IDS to IPS. So what you should do is whitelisting, but a lot of people don't do that. So let's have a look through the questions now. The attacker ran host discovery scans using decoys. What are the decoy IPs? That'll be in the packet capture. The attacker ran 3 different host discovery scans. What scans were performed? How does Suricata classify the second type of scan? What is the event generated? Find the web server inversion. The port used for the exploitation and the service listening on the port. What CVE? What is the CVE, the name of the vulnerability, and the type of the successful exploit? What is the username and password of the compromised user? What mode Suricata is running in? And what is the name of the rule set used by Suricata? So this might be likely the IPS IDS and then the rule set that Suricata uses. What is the vulnerability assessment tool and the feature used by the threat actor that was detected by Suricata? What is the name of the failed exploit and what is the reason for the failure? What is the name of the payload? Yep. What is the port the threat actor tried to get a reverse shell on and what is the language of the shell? What is the action taken and the classification of the successful exploit? What is the file that the threat actor successfully leaked from the vulnerable service? What is the file the attacker queried to view the compromised user permissions and what was the UID? The compromised user, the attacker, what the command used to obtain root. Okay, so there's a lot here. There's a lot of questions that have multiple answers that need to go in straight up. So I remember playing this before I joined Security Blue Team and the BTLO team to make labs and do these kind of things. And this was, I don't think, a hard lab. I think this was a medium lab. What made this hard, and it was kind of a running thing within the community, like some labs are just hard because of how the formats are and the fact that you have, if you like, for the example, let's say like this one was a CVE, the name of the vulnerability, you start to get permutations of what you can enter into here based on if there's not enough different ways that you can answer things like the name of the vulnerability, because that could have multiple names. The name could change. It could be abbreviated. And then the type of vuln, you have multiple. The CVE shouldn't change, but these two kind of things then mess up your answer for this long string that you're trying to enter. There was a few others. So, and full disclosure, like I generally try and run through the labs quickly beforehand. I ran through the lab again before filming, and this one took me an hour and a half. So I'm going to run you all through it to show you all my thought process on how I get all these. I'll highlight where I disagree sometimes, and there'll definitely be times where I kind of jump over where I struggle to get the answer and I literally brute force it, and I can show you the thought process to get to it. But it's definitely one of those labs that is just frustrating because of the formatting of the questions. It's something that our QA process has definitely tried to get better, but for now, let me jump into this and show you guys Ghosted. So here we go. We're going straight into the investigation files. We've got a auditd TTY report. We'll have a look at that. We've got a Suricata log and we've got the traffic PCAP. So let's open this because it may take some time to open. And then let's jump into terminal and I'll jump into full screen. Let me go to preferences. I'll make the font a little bit bigger. So I'm going to go custom font. I think 20 was a sweet spot for us from one of the other labs I did. Okay, 20 was good. I also want to get rid of this white because it's hurting my eyes. Custom colors. Here we go. Let's open up the questions. Should be able to stay in full screen mode this whole time. Oh no, actually, my apologies. There is a few things that we need to Google to do OSINT on. So we're going to do that. Here we go here. Okay, and let's set up Wireshark now for the same. Okay, so let's change into desktop and then into the investigation folder. So we've got these things here. Let's have a look at the auditd log straight away. So what this is essentially like the batch history from the machine. So the auditd is like, I think it's like a service that runs on Linux that'll record and store it in a file for you. So we've got date, time, event, AUD. So this is the user that it's tracking. So we've got the date, the time, the event, and then 1000 is the user. So if you look down on the bottom, there was questions about this. So I wanted the UID, which is 1000. And then what is the command used to attain root? So towards the end, well, let's go through all of this. So it's going, they go, who am I? They're trying to figure out who they are. Then they're doing ID to get some more information about the user. They're doing an LS to see the directory that they're in, like what's in the directory. They're trying to do a cat Etsy password, which I don't think they can do as a user. They won't have permissions. Then they do a uname tac A to get more information on the machine, ifconfig to get more information, up A to get more information. Then they do a sudo tac L. So what a sudo tac L does is will feed you back the permissions that, or essentially the permissions that the user has to use sudo for on the system. So we can test that here. So if we go sudo tac L, my user can do whatever they want. So the Ubuntu user can do all commands, have no password on everything. Now, on a normal machine or in an enterprise environment, what you want to do is lock this down, and you may need the user to still run some commands as admin. You should always leave the password on, but what some people do is go, hey, we're going to give them permissions to run sudo on this binary only, and then that's all. That's kind of all the administrating privileges that they have, which is a bad idea because there's lots of vulnerabilities in different binaries. So what they're doing is trying to see what permissions they have. And then sudo tac I, if you look up Linux lol bins, sudo tac I, if they have the right permissions from tac L, is the privilege escalation path. So I'm not going to go into that now because this lab will already be long enough. Oh, and I can't copy out. So sudo tac I. And there we go. And then that also leads us to what is the file that the attacker queried to view the compromised user permissions? So what sudo tac L does is it actually queries the Etsy sudo ers file. And again, like this is a Google question to do about when you run sudo tac L, what file is it querying? And that's the answer there. So we've got both of those. Now, what is the file that the threat actor leaked from the vulnerable service? We'll get to that. So for now, that's all we're getting out of the auditd one. It was the very last questions that we have. It was just an easy win to get some points on the board. And now let's jump into the PCAP. So the attacker ran host discovery scans using decoys. What are the decoy IPs? What we want to do is we want to figure out what the host is, and then if they're running scans, there should be a lot of packet traffic because it's just hitting a lot of things. So that's kind of what we're looking for. So if we go statistics endpoints, and then most likely they're running, well, we can have a look at IPv6, there's no traffic. IPv4, and then we're going to sort by packets. So we can see here 192.168.10.100 is likely to be the host machine, which I don't think, I didn't even question this before, but I don't think it's this machine. I think they just dropped, oh, it's in, yeah. So they've just dropped the artifacts on the box. It's not actually this machine that was compromised. Okay. So then we've got 5.179.123. The top packets are the decoys. So because these are all similar, this is likely the attacker machine, so 80.5. And then they're using decoys to scan, and you can see it's roughly about the same traffic. So that's why this is decoys. And then it wants it in ascending order. So 172.16.80 dot, and then we'll just copy that. And then we're going 79, 123, and 221. First answer there. The attacker ran 3 different host discovery scans. What scans were performed? Let's assume that they ran the same scans on each machine. If that hypothesis was not correct, we can then go through each of the IPs. What we're looking for is the flags that are being set to kind of determine these scans. So I'm going to go IP, or I'm going to go IP source, because we kind of only care about what it's sending at this point. 80 and 79. And then we want to open up the TCP, and we're looking at the flags. So the first thing that we see here is all zeros, so nothing's set. So that's known as a null scan. And then let's jump to the end. Let's see if we can notice anything. So likely a SYN scan, or it's also known as a stealth scan. And this is where this gets confusing, right? Because there's multiple names for these kind of things. So if SYN scan doesn't work in this, then we need to change that and then try and guess. I actually can't remember what this one was. And then the last one, we kind of want to go like midway. We're hoping that when they were setting up this lab, they kind of just made it a bit nice. Looks like we're still getting a lot of SYN scans. A lot of SYN scans. Let's jump back up maybe halfway again. Fin push erg. Okay. So this is what is known as a Xmas scan, because it lights up the packet like a Christmas tree. So yeah, again, like there aren't other names for this. You can kind of Google around Nmap and what each of these scans are. I think, yeah, okay, it's a SYN scan. When I originally did this, because it uses Xmas scan here, I use stealth scan a lot, and it was just painful. Big shout out to the community though. Like as I was struggling through this lab, I pinged a lot of people all the time, and they were really happy to help, especially when I had the answer. I just didn't have the format. They were more than happy to kind of just nudge me in the right direction. How does Suricata classify the second type of scan? What is the event generated? So what we're going to have to do here is now go into Suricata on one of these and then hopefully have a look at it. So what I did here is we're going to go time display format, and you'll see why in a sec. And we want to go date, time of year. So we're going to try and look for 1956-09. We're going to try and look for this time. So let's go back to the command line, and we want to do We want to grep for, I forget what are they grepping for here. We want to grep for, I don't even think anything at this point. I think maybe we just want to let's just have a look at the Suricata logs. So we have a lot of logs here, and then we were looking for, oh, no, go away. That jumped on me. What were we looking for? 195609. So what you can do is go / 195609. And then we want to look for 624363. 624363. Now, what we're hoping here is that there's no deviation in the time between the PCAP and then the Suricata logs. And the reason why I changed the time format was because it's in that time format in here. So we got to hit here, event type anomaly. We've got the source IP, which is correct, and the destination IP. So it looks like we've got the right thing. And then the question was, how does Suricata classify the second type of scan? What is the event generated? So what's the classification and event? Now, this is where you run down another rabbit hole where the Suricata implementation and then the Suricata documentation deviate, which is insanely stupid to have to deal with. And people have to deal with this all the time because you use Suricata in your day-to-day work. I wasn't super familiar with Suricata, so dealing with this was troubling when I was first doing this lab because it's difficult to understand this on top of the fact that the lab questions weren't designed personally, I think, very well. But what it's asking for is the classification is actually the event type. So what it wants here is anomaly, and then the event is the event. So it wants the stream.fin, but no session. So that's what we're going to do here. And I'll show you where this gets more confusing later on. So if you kind of get one of these first and then you try and do the other questions, it gets even more confusing. But no, what was it? No session. Yeah. Find the web server and version, the port used for the exploitation and the service listing on the port. So what we're going to do here is search for, I think I grabbed for web. So TACI for case insensitive. We're going to look for web. We're going to look through the Suricata log text, and then we're going to less. Yes, that's what we want. So we're seeing Nmap scripting engine being used here, which is good. We kind of knew that from the fact that we're looking at all these different types of scans. Nmap makes sense. And then what we're looking for is web server name and port. So we're kind of just going to look through some of this stuff. I'm going to highlight it so it's easy to read. I didn't miss anything there, did I? So much harder to read when this is larger. We might do, yeah, let's search for web, and that'll highlight all the webs. So we've got a payload here. So we could see, this could be one of the other questions. So let's grab this while we're just going through and have a look at it. We should have CyberChef. So let's open that up. What it looked like was base 64, so we're going to decode that from base 64. Okay, so web.xml. Could be interesting. Let's come back to that. So let's go back here. This looks like it is part of an attack. We've got a CVE 2020-1938. So that could be this one. Was the CVE and the name of the vulnerability, the type that was used? So, of course, I can't copy out. CVE 2020-1938. And then this was, so look at the format, name of vulnerability and type of vulnerability. Name of vulnerability is GhostCat LFI attempt inbound. Let me just check. So this was question 5. Okay, yeah. So from my notes, what it wanted was GhostCat, and then it wanted the type of vulnerability, and the type is LFI, but pretty sure it won't accept LFI. No, what it wants is local file inclusion. So they're not accepting multiple things, even though it says LFI here. Okay, so we're still looking for the web server. Let's keep having a look. Maybe if I search for server, because we've got a lot of hits for... No, I'm going to get the to server. Okay, web server affected product. So Apache Tomcat is a type of server. So let's look for Tomcat now. So we're pivoting. Pattern not found. Oh, is that because... Must want me to go back to the top. Wonder if this is search down only. Oh, let's just quit and we'll come back in. And then let's search for Tomcat now that we know that. Oh, there we go. It was right near the top. We just missed it. So Apache Tomcat. Port and service. Okay, so Apache Tomcat 8520. And then do we have... So no, because it's broken it up. So it's this top packet, destination port. We know this is the host. Destination port's 8080. So yep, port was next. 8080. And then this was one where I Googled the service. So let's do that. So Apache Tomcat service running on port 8080. What service is running on port 8080? So what we're doing at the moment is trying to find the service that's running on it. Open the port tab, you'll get the following: Tomcat admin port, HTTP, AJP. So heads up, that's the service, AJP, according to my answers. I'm just trying to find when I did this lab originally where I got that from so that it's clear. I do remember researching this quite a lot though. So maybe it's just clicking around until it kind of pops out. Yeah, it wasn't helpful. What if we get some clarity on this and just search Apache Tomcat AJP service? I'm seeing a lot of where it's like saying protocol. They call it a connector. Yeah, so again, like maybe this is a question thing. The AJP connector element represents a connector component that communicates with the web connector via the AJP protocol. And you can see this protocol in Wireshark. It will dissect it correctly. This is used for cases where you wish to invisibly integrate Tomcat into an existing or new Apache installation. So it doesn't call it a service, which is confusing. There's only one element on this page. Service as an element represents a combination of one or more connector components. Right, okay. One or more service elements may be nested inside a server. Yeah, so when I was doing this, I didn't find service instance. Does it tell me? What if I do... Go back to full screen. So AJP is not found within the Suricata logs. If I look for service, like HTTP is a service, HTTP, I'm grepping for web. So what if I grep for AJP? Which means that I should have some in here. Pattern, what? Pattern not found. Oh, because I grep for it, but it's still less of it. AJ, yeah. That should give me no results. Okay. Anyway, if someone knows a way to find this, please hit me up on Discord. I'm not going to get into what a connector and what a service is for a web server. This was a tough one, again, because it was like multiple things in a row. And then you're questioning whether it's the right server. So I do remember I went back and started looking for other web servers because I didn't know whether I had the right web server. Yeah, tough one. What is a username and password? So we've got the local in file inclusion. So let's see if we can find that again, because that gives us a hint. So ghostcat, pattern not found. Let's go for CVE 2020. So that's what we want to look for. And then what we're looking for here, destination IP. Yeah, so what we want is destination port. So we know that this exploit was successful. 8009, so if we Google that, 8009 is the administrator port for the Apache Tomcat server. So what we want to now look for is the IP of this, because it could be any other IPs attacking it, but let's just look for this one. And then we also want to look for the TC port of 8009. So let's get into that. Here we go, and TCP port 8009. Cool. So we've got a whole bunch of things here. Let's just scroll down a bit. Okay, so we're not seeing heaps, but let's follow this stream. I forget which stream that it was that I looked at. Here we go. Welcome to Tomcat. So we've got J Reese, admin. Not necessarily a difficult password to get. Twice the admin as usual. What mode is Suricata running on, and what is the name of the rule set used by Suricata? So again, this is where I use some OSINT. Let's go look for Suricata default mode. Google for. Yeah, so here we go. Suricata by default is installed as a passive IDS, so IDS. And then we need to figure out, the next thing we need to figure out is what rules it uses. So we're going to search for what are Suricata's rules based off. And then maybe DigitalOcean. Saying security rules. Suricata is installed, blah, blah, blah. The ET open rule set downloaded. So let's go here. And then, I got stuck here for ages. So this is what I did. I went IDS and then ET open source. And then ET open, wrong again. So you see in tools, so the ET rule set is actually used quite a lot. But what this question wanted was emerging threats, which, yeah, it just says rule set name. So again, I probably would have written this question a little bit better or done the format a little bit better. I guess this is a hard lab. It's a difficult one between being hard and then just being confusing. Because, I mean, ET open rule set is the same as emerging threats. It's just, semantics between the two. What is the vulnerability assessment tool and features used by the threat actor that was detected by Suricata? So again, so we know it was Mmap. That's not it. Mmap scripting engine. Okay, it accepted that. What is the name of the failed exploit and what is the reason for the failure? So here, when I was going through this originally, I spent a lot of time looking for CVEs. Sorry, let me go back into full screen. So what we want to do is we want to search for just the CVEs. And then I should be able to see. So here we go. There's another CVE here where it tries to do a JSP upload bypass attempt. We can see though, so we know that the one that worked was from 2020, and then the one that they is trying to use here is from 2017. So it's likely, if you look up like exploit database or exploit DB, as it's also known, you would probably find that based on the version of Apache Tomcat, the 2017 exploit won't work against it because it would have been patched. So it's likely what the attacker has done is tried an exploit because they were like, oh, it's an Apache Tomcat server. It didn't work. And then they're like, I need to check the version. And then they're like, all right, I have to use a more updated exploit. And they went and did the 2021. So this one, failed exploit name. I had trouble here again trying to like get the name because it's this JSP upload bypass attempt or JSP upload bypass, I guess. And then what else did I want? The reason for the failure. So the reason for the failure is we keep looking down here and this packet doesn't really give us a reason. But what we're looking for is like a response from the server as to why it won't work. So where are we going? We're going to HT. It's trying to put something, as we can see here, where it's trying to put this file. And then we get a 403. So a 403 is like, we can look this up, but it's like a forbidden. So HTTP 403. Yeah, forbidden. So you're not allowed to do it. You need like credentials or something. And maybe that's why this failed, is because you needed to be authenticated for it to work. And again, like you can go look up that CVE and see the see the reasons why, or the prerequisites you need to get that exploit to work. So we can just go 403, but I didn't get that. That took me a while to get. I think what it wants is, I think it wants the forbidden. It wants the forbidden, so yeah, there we go. All right, so on to the next one. What is the name of the payload of the failed exploit tried to upload to the vulnerable server? So once the payload and the extensions, we already had seen this. It's this one, and again, I can't copy out, so we'll just type it. So gdwuj uvvff.jsp. If this wasn't in here, we know that the exploit is a JSP upload bypass. So we'd actually jump back out and then just search for .jsp and try and find it, because they likely would have named the upload with the correct file extension. Was the port the threat actor trying to get a reverse shell on, and what is the language of the shell? So this one is, how did I do this one? Oh, so we have this bunch of request stuff. I wonder, I had in my notes that I was like, I spent a lot of time on this lab. I spent a lot of time decoding these. I think, could be this one. Oh wait, it's like here. It like decodes the payloads for us. So that's what I'm looking at now. Because it's payload principal. What we could do is we could go, let's go payload printable. And then search for principal so we can just see it. Right, so it appears in pretty much everything, which might not be as helpful. I wonder if I can go backwards. Minus, I wonder if I can go backwards with cut. -1, -2, -3, -4. I'm going to try this. So I'm going to cut delimiter on a comma, field field to be -4. And I want a less. No, okay. So I need to count forward. Printable. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I want the 25th field. Right, and then some of the packets are different. Okay, so I want the 25th and 26th field. Right, some of these payloads are just rubbish. signature, attempt gain. And some of them are not hitting on packet info. Yeah. Okay, that's the end of it. So looks like it's towards the bottom. It's the one I forget how I did. All right. Sorry, I had to go to it and then come back to it, and I figured out how to pivot on this one. So the last question is, there's a failed exploit. And this is where this question leads on, but it's not necessarily clear. But, and I can't paste. But what we're looking for is, we want to look for that file that we just got for that previous answer. And I kind of wish I copied it into my clipboard in here, but that's okay. So we're going to look for gdwjuVBFF.jsp. All right, so we got some hits. So we've got the file name here, and then what we want to look for is hopefully the contents of that file and what it was trying to do. So we can see, so it's importing java.net, so that's likely the language. And then it's got OS name, it's finding the shell path, and then we come down here, we know this is the attacker IP, and then it looks like it's trying to call back on 445. So 445.5, and then Java, because it was importing the Java. And there we go. We got that one. Awesome. Okay, next one. What is the action taken and the classification for the successful exploit? All right, so this one we know is the 2020 CVE. So we're going back to that. So let's go CVE 2020. Still looking in the Suricata logs, and then action taken and the classification. So where are we here? Where are we here? We want to look for this one, to this line. Is it this one? And then we're looking for the action. Okay, so here's an action allowed. And then what else do we want? We want the classification. The classification is, I think this one's where it's different. So this is where documentation of Suricata is again different from reality. Yeah, so it wants the category, not the classification, but we've got the classification here. And then the format for this one tricked me up as well, because it actually wants this action stuff in, which it, to its credit, it does have it here. I guess this was a very frustrating lab to do at the time. So we know the action is allowed, and then it doesn't want us to write category. It wants us to write classification. And then it wants us to put in the attempted administrator privilege gain. Oh, and I can't spell administrator. Administrator. No, that's not what I wanted. Attempted administrator gain. Let me have a look at category. We've hit the 2020, so Action allowed, classification. Definitely was privilege gain. Am I not spelling privilege correctly? P-R-I... yeah, I think I was spelling it wrong. No? Remote gain. Okay, what's going on here? Let's just search for privilege. And then let's search for gain. Pattern unfound. Ah, is it this one? APG connector arbitrary file access. Rule set community. Policy is IPS to drop. Actions allowed. So it allows both. Is this part of this? What is this part of? Doesn't tell me. Okay. So it does the user one as well. So let's. Right. Okay. So it's the user one. What is the file that the threat actor successfully leaked from the vulnerable service? Oh, this one? That's the one we found before that I think we found interesting. I don't think I kept it. APJ. Was it this one? TCP stream? Java's doing a request, and then it's grabbing the web XML file. Yeah. And there we go. That was ghosted. So yeah, definitely a hard lab. I think there was some trickiness with the questions, in all fairness. There was definitely, with hard labs and some of the medium labs that we do, there's definitely some background knowledge or prerequisite knowledge that's needed. In this case, it was in server administration and particularly the Apache Tomcat. Some of the questions were hard to get just around terminology. So the thing about the service being the AJP, a lot of the Google searches that you were doing pointed to it being a connector, with the fact that a service could be one or more connectors, which made that more difficult. Thrown on top of the fact that Suricata, how their documentation works is different from their implementation, which is very frustrating, but not the lab creators' problem. And it highlights some of the issues within the industry for tool sets and the reason for making good documentation. So I came out of this, like I learned a lot. I just remember banging my head against the wall for weeks on this one. It definitely was a very hard lab to just grind through. And I remember closing this down and being like a week later, oh, okay, I'll start up Ghosted again and get to it. But for those people out there that struggle, know that everyone struggles. I struggled with this one. We look at some of the times that some of the top players take, and they spend hours and hours and hours in these labs. So it's a grind for everyone. And as long as you get to learn something out of it, which I have, I think, out of every single lab, then that's the key. But no more ranting from me. Thanks for watching. Be sure to like and subscribe to never miss a video. And in the meantime, remember to join us on Discord, because that's how I grinded through this lab, was through the people that they're an amazing community. We've got some amazing people joining the team. And also tune in every Friday, 6 p.m. BST for BTLO Replay. Thanks everyone, and I'll see you all next time.